Every time you deal with function in mathematics, you have to think about domain and range. Domain is the place where the input x lives in a function, and range is the place where the output y lives in a function. So let's use a graph. So we have x-axis, we have y-axis, and then we have a curve. The curve is represented by f of x. So let me just drop it down for you. So the curve represents f of x. So looking at this curve, can you tell me where the domain is? So to look for the domain, you have to look for x. All right, so every time I say the word domain, think about x. It is just that easy. So this graph has two endpoints, one at a comma b, one at c comma d. So looking at the x, so the x goes from a to c, right? X goes from a to c. So what is the smallest possible x value? The answer is x equals to a. What is the biggest x value? The answer is x equals to c. So from a to c, so we say this domain is x is between a and c. It is just that easy. And then what about range? What is the smallest y? The smallest y is y equals to b. The biggest y is y equals to d. Or you can look this way. So the smallest y to the biggest y, right? So the range is y is equals to the smallest y again is b. The biggest y is again, that is d. So it is just that easy. X is between a and c, y is between b and d. And then based on this problem, we have a graph, right? You can see everything. So what if you don't have a graph? So if you look down below, I have 6 functions for you. Assuming we don't know what the graph looks like and we don't have a graphing calculator. So how do you find out the domain and range of those functions? So find the domain and range, just find the domain, don't worry about the range. Find the domain of the following function. There are 3 useful things to keep in mind. Number 1 is for rational function. What is rational function? The first one, f of x equals to 3x plus 1 divided by x. That is called a rational function because we have a function on top, a function on the bottom. So we have a fraction. There is a function on top, and then there is a function on the bottom. So that is called a rational function. First thing first, keep in mind that denominator cannot be equal to 0. And then if you see a square root like the next one, f of x equals to 5 minus x, you have to make sure the quantity inside a square root must be non-negative. Because the square root of 0, that is okay. The square root of positive is okay, but if you take the square root of negative value, so the square root of negative 3, that is undefined. So that's why we have to make sure the 5 minus x must be non-negative, okay, cannot be equal to negative. And then number 3, so if you see a cube root like f of x equals to the cube root of 5 minus x, then 5 minus x can be 0, positive or negative. I will explain why in a minute. So first of all, let's deal with the first one. So the first one is f of x equals to 3x plus 1 divided by x. So we have f of x equals to 3x plus 1 divided by x. So this is a rational function. First thing first, we have to look at this x. We have to say that this x cannot be equal to 0. All right, so that is the first restriction. Anything else? Can x be equals to 1, 2, 3, 4? Of course. How about 3x plus 1? Does that affect the domain? The answer is no. Look, 3x plus 1 is in the numerator, right? So for 3x plus 1 that is in the numerator can be 0, positive or negative. So basically 3x plus 1 does not affect anything at all. So our only restriction is x cannot be equal to 0. So this is the only restriction. And then other than that, I usually ask my student to draw a number line. So what is a number line? So number line is a straight line. And then you have 0 in the middle. You have positive numbers on the right and negative number on the left. So that as as you move to the right, the numbers are getting bigger and bigger. As you move to the left, the numbers are getting smaller and smaller, right? So x cannot be equal to 0. So this is like using a hole puncher. You punch a hole at x equals to 0. So I cannot draw anything right there. And then what else? That's it. So x can be positive, x can be negative, except 0. And then this is the number line. So let's call this number line. Label this. And then the one last thing that I usually ask is called an interval. So from 0 to beyond, what is the interval? The interval is from 0 to positive infinity. And then on the other side is from negative infinity all the way to 0. So this is called interval notation. For interval notation, you use a comma to separate two numbers, small number on the left, big number on the right, because that works just like the number line. You have big number on the right, small number on the left. And then the reason I used one arrow at each end is because if you look all the way to the right, the number is positive infinity. You look all the way to the left, the number is negative infinity. For real numbers, there is no largest real number, so that's why we use infinity. There is no such number, right? You cannot write such number on a piece of paper, so therefore mathematicians said, why don't we just use a positive infinity to represent something that we cannot draw on a piece of paper. Same thing on the other side, the negative infinity. So now you know how to find the restriction, put the restriction on a number line, and then use the number line to draw the interval. So this two interval stands for the domain of the function. Of course, you can put this using inequality. The inequality is x greater than or equal to 0 or x less than or equal to 0. We use the conjunction or because every time you put a number to the function, you choose one number, right? So let's say you choose x equals to 5. The 5 is either in the first interval or in the second interval. So that's why you use the conjunction or, but sometimes people, instead of using or, they just use a comma to separate the two intervals. All right, so moving on to the next one. The next one is f of x equals to the square root of 5 minus x. Before we start, I would like to review the graph of square root of x. So the graph of square root of x looks like this. You start at the origin 0, 0, and then you draw an increasing function. So that is square root of x. So x can be 0 or x can be anything greater than 0, right? So x must be greater than or equal to 0. So if you consider the function square root 5 minus x, the entire quantity inside the radicand must be greater than or equal to 0. Because if you have square root of negative, that is undefined. Square root of negative 5, negative 10, negative 1,000, they are all undefined. And then you solve the inequality. So we subtract 5 on both sides. 0 minus 5 is negative 5. The reason I give you a minus x is the next is to review this. When you multiply or divide, write this down. When you multiply or divide both sides of an inequality by negative, you have to reverse the direction of the inequality symbol. So I'm going to divide both sides by negative 1 or multiply both sides by negative 1. You have to reverse the inequality symbol. Let me say this again. When you multiply or divide both sides of an inequality by a negative quantity, you have to reverse the inequality symbol. It can be negative 6, negative 10. As long as that is negative, multiply or divide, you have to flip the symbol. Okay, write the result. We have x less than 5. Okay, so this is domain. And then we put this on the number line. So number line, you can just simplify your number line 0 and then you put the 5 in there and then skip the rest of the numbers after you did some practice. So x can be equal to 5, right? Do you see that there is an equal? So this one we use a solid circle and then less than is this side. So that's the number line. And then for the interval, we go from negative infinity to 5 square bracket. What is square bracket? Square bracket means x can be equal to 5. So this is called a square bracket. So that means when you pick a domain, x equals to 5 is okay. If you use a parenthesis, that means do not let x equals to 5. All right. So that's the next one. So moving on to the next one. The next one, I believe that we have a third power, right? So we have a third power. Okay, so let's move on to the next one. The next one is f of x equals to the cube root of 5 minus x. I didn't change the radicand. Okay, so this one, what is the graph of the cube root of x? Just the cube root of x. Maybe I should do this in a different color. So we just review the graph of cube root of x. So the graph looks like this. We have one piece goes there and then the other piece goes there. The origin is at 0, 0. That means we can have cube root of negative, we can have cube root of 0, and then we can have cube root of positive. They are all defined, right? They are all defined. What does that mean? That means x, 5 minus x has no restriction. What does that mean? No restriction means x can be any value. So x can be any value. So how do you express this on a line? You have 0. Then there is no solid circle, no open circle, just one line. So that means x can be from negative infinity to positive infinity. When you select one x value, select anything you want. Another way to say this is x can be any real number. Pick anything you want. So that is for the cube root. All right. So let's move on to the next one. The next one we have is we have f of x equals to the square root of x squared plus 1. And then you are immediately thinking, all right, I have a square root, okay, then x squared plus 1 greater than or equal to 0. That is absolutely okay. But do we really need to solve this inequality? Is x squared plus 1 always greater than 0? Think about this. Just take 5 seconds. Think about any number, positive, negative, I don't really care. Okay, let's think about negative. You square a negative. That becomes a positive already, even though you choose a 0. You square a 0, you have a 0. 0 plus 1 must be greater than 0. Let's say you pick negative 5. Square negative 5, you get 25. 25 plus 1 is greater than or equal to 0. So that means it doesn't matter what numbers you pick, x squared plus 1 is always greater than 0. If you want to graph x squared plus 1, that is a parabola, and shift 1 unit up at y equals to 1. So this one, x is always greater than 0 because the entire graph is above the x-axis. So this means x can be any values. And then this is the number line, 0, x can be anything you like. And then you go from negative infinity to positive infinity. So that means x can be any value or x can be any real numbers. Okay, moving on to the next one. The next one is we have x plus 3 raised to a rational exponent. So let's pick this color. So we have f of x equals to x plus 3 raised to this rational exponent. So this one we can modify that a little bit. So x plus 3, how about this? I keep the 1/2 inside and then toss the 3 outside. So this one you can, by the law of exponent, when you multiply the 1/2 and the 3, you get 2/3, right? So the 1/2 becomes a square root x plus 3, and then raise that to the third power. So when you raise that to the third power, I don't really care, right? Because any number, pick any number you like, raise to the third power, the result is okay. You will never get something that is undefined. So the only thing that we have to pay attention to is x plus 3. So since you have a square root, then x plus 3 must be greater than or equal to 0. You can use the equal because 0 raised to the third power is okay. And then x is greater than or equal to, subtract 3 on both sides. Then there you go. That is your domain. Graph that. 0, negative 3, greater than or equal to. So the line goes to this side. So this is from negative 3 to positive infinity. That's how easy it is. Last one. The last one is f of x equals to x squared plus 3. Are there any restriction? I don't think so. You square a number, you add 3 to it. you can always get an output, right? So this one, if you think about the graph is a parabola and shift 3 units up right here. So this x can be any value you want, right? So x can be any real number. And then the number line is, I put a 0, so that tells my grader that left side is negative, right side is positive. We just shoot a line through, and then from negative infinity to positive infinity. You square a number, you add 3 to it, you can always get an output. There is no restriction on that. Alright, so that is the end of this video. If you think my instruction is helpful, give me a like, share the video for me, subscribe to my channel if you're on your way out. Thank you for your support. I will see you all in the next one. Signing off for now.